There are many versions of the second law of thermodynamics. In this lecture, we will present the version by Kelvin and Planck. In the previous lecture, we looked at a cyclically operating heat engine. Heat engine is that which converts heat energy to work. Because the heat engine is operating in a cyclical manner, the starting point and the ending point should be the same, right? Once you complete a cycle. For example, here's a gas. It obtains heat from a hot reservoir, lifts mass and produces work. But because it's operating in a cyclical manner, the gas has to be brought to the original state. So for doing that, some heat has to be transferred, and heat can be transferred only from high temperature to low temperature. Therefore, a heat exchange to a low temperature reservoir has to occur. Because of this, not all of the heat that is supplied can be converted to work. In this case, this 15 kilojoules is converted to lifting the mass. All the rest goes into heating the gas, expanding the gas, and some of the heat is being released to the environment. We also saw this in another version. There is molecules that are heated up by high temperature reservoir. That means they have, when you say the heat is obtained from high temperature reservoir, temperature is indicator of the kinetic energy of the gas molecules. It hits a piston. The piston is moved to generate work. However, after collision with the piston, there is a finite velocity for these gas molecules, which go to the low temperature reservoir. Because of this finite velocity for these molecules, the efficiency is not 100%. Okay, so in both these cases, we have some reasons why the efficiency is not 100%. So all of the heat that is being supplied can never be converted to work. It is important to understand this less than 100% efficiency of heat to work conversion is not due to frictional losses or any other dissipative losses. Okay, so here we are not really considering issues of friction for rationalizing the less than 100% conversion of heat to work. Even without friction, the efficiency is less than 100%. So all this is encapsulated in the Kelvin Planck statement of second law of thermodynamics. It states that it is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. Or if the heat engine receives 100 kilowatt of power from a high temperature reservoir, you cannot get 100 kilowatts of work, right? And this because this cannot be zero. That is, the power that is rejected to the low temperature reservoir cannot be zero, because the heat engine operates in a cyclical manner. Okay, so the fluid that is part of the heat engine has to come back to the same point. It's the same thermodynamic point as the heat engine converts heat energy to work. Okay, so this is one statement of second law of thermodynamics. We will see that the second law of thermodynamics can be presented in many different forms. Here we are presenting the Kelvin Planck statement. Next, what we will do is we will look at refrigerators and heat pumps. Corresponding to that, we can present the second law using the Clausius statement. We will also see that all these statements of second law are one and the same. We'll also go about proving that in the next few lectures. Thank you.